Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the equation of a circle practice questions. If you need any extra help on the equation of a circle, if you go to corbettmaths.com and go to the videos and worksheets section and scroll down to video number 12, there's a dedicated video tutorial there on the equation of a circle. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says the equation of a circle C with centre O is x squared plus y squared equals 225. And part A says find the coordinates of the centre O. Now if we have a look at this equation, we've got x squared plus y squared equals 225. And whenever you get the equation of a circle in the form of x squared plus y squared equals a number, the centre of that circle will be the origin. So the centre of the circle is the point 0, 0, because it's x squared plus y squared equals 225. So that means the centre of the circle is the origin, 0, 0. Okay, part B. Part B says find the radius of circle C. So we've got the equation of a circle is x squared plus y squared equals the radius squared. So here we've got the radius squared. So 225 will be the radius squared. So that means that the radius squared is equal to 225. Now obviously if you wanted to solve this equation, you get that r equals plus or minus 15 because it could be 15 or negative 15. But with it being the radius of a circle, it can't be a negative radius. So therefore, if we square root this, we're going to get that r is equal to 15. And that's it. So the square root of 225 is 15. So that means the radius of the circle is 15. And that's it. Okay, then part C. Part C says show the point with coordinates 9, 12 lies on C. So here we've got our point. We've got the point 9, 12. That's the x coordinate and the y coordinate. And we've got the equation of the circle being x squared plus y squared being 225. So x squared plus y squared equals 225. And if we substitute in the x coordinate and the y coordinate, and we get that's equal to 225, that means this point lies on the circle C. So let's do that. So x squared, that's going to be 9 squared. Plus y squared, that's going to be 12 squared. Hopefully that's going to be equal to 225. So let's see if it's equal to 225. So 9 squared is 81 plus 12 squared is 144. And that's equal to 225. And let's just check. 81 plus 144 is equal to 225. So 225 equals 225. So that means that point satisfies the equation of the circle. So that means that it does lie in the circle. And that's it. I've just written down 9, 12 does lie on C. Okay, let's have a look at our next question, question number 2. So question number 2 says the circle's get centre is 0, 0, or the origin, and radius 6. And part A says write down the equation of the circle. So remember GCSE level, the equation of a circle will be x squared plus y squared equals r squared. We've got x squared plus y squared equals the radius squared. So x squared plus y squared equals r squared. Now the radius is 6, so it's going to be x squared plus y squared equals 6 squared. Now you could leave it like that if you wanted to. I tend to square 6 to get 36. So I'd write my answer as x squared plus y squared equals 36. And that's it. So that's the equation of a circle, which is the centre at the origin, or 0, 0, and radius 6. Okay, next, part B. Part B says, does the point negative 3, 5 lie on the circle? So we've got our x coordinate and our y coordinate. So if we substitute those into the equation, does it equal 36? So we've got x squared, so that's going to be negative 3 squared, plus y squared, which is 5 squared, and does it equal 36? So negative 3 squared, well, that's going to be negative 3 times negative 3. Remember, negative times a negative is a positive, so negative 3 times negative 3 is 9, plus 5 squared is 25. So we've got 9 plus 25, and does that equal 36? Well, 9 plus 25 is equal to 34, and 34 does not equal 36, so it doesn't equal 36. So does the point lie in the circle? No, because x squared plus y squared does not equal r squared, the radius squared, and that's it, because we've got 34 does not equal 36. So does the point lie in the circle? No, and that's it. It doesn't satisfy the equation. Okay, let's have a look at our next question, question number 3. So question number 3, we've been given a circle drawn for us on a set of axes. We've got our x-axis and our y-axis, and we've got this circle, and we've been asked to find the equation of the circle. So the centre of the circle is the origin, so it's going to be the form x squared plus y squared equals the radius squared. So it's going to be x squared plus y squared equals the radius squared. Let's find the radius of this circle. So the centre of the circle is the origin, the point 0, 0. It passes through the point 2, 0 here. So that means the radius of the circle is 2. That means the radius of that circle is 2. So we're going to do x squared plus y squared equals the radius squared. So the radius is 2, so it's going to be 2 squared. And 2 squared is 4, so I would write it as x squared plus y squared equals 4, and that's it. That's the equation of that circle. Because the circle is going to radius to 2, it's going to be x squared plus y squared equals 4, because 2 squared is 4, and that's it. Okay, let's have a look at our next question, question number 4. So question number 4, we've been asked to draw a circle with equation x squared plus y squared equals 16. So remember at GCSE level, the equation of a circle is x squared plus y squared equals the radius squared. So if we want to find out what the radius is, we just need to square root 16. And the square root of 16 is equal to 4. So that means that we've got x squared plus y squared equals 4 squared. And that means the radius of the circle is 4. So we just need to draw a circle with radius 4 and the centre being the origin, 0, 0. So let's do that. And that's it. I've just drawn that circle. And as you can see, the circle's got a centre of the origin, 0, 0. And it's got a radius of 4 because it passes through 4, 0, 0, 4, negative 4, 0, and 0, negative 4. And if you were to do that, you would get your pair of compasses. You would set the point of the compass at the origin. You put your pencil on the point 4 here, 4, 0, and then you just draw your circle. And that's it. Okay, let's have a look at the next question, question number 5. Okay, let's have a look at question number 5. So question number 5 says a circle's got centre 0, 0, or the origin, and radius 9. And Roberto says the equation of the circle is x squared plus y squared equals 9. And Pi says explain Roberto's mistake. So the equation of a circle at GCSE level is x squared plus y squared equals r squared, where we've got x and y, and then we've got the radius r. So with this circle we've been given, we've got x squared plus y squared equals the radius, which is 9 squared. So the equation of the circle is x squared plus y squared equals 81. And if we have a look at Roberto's answer, he's written x squared plus y squared equals 9. He's not squared the radius. He's just written down the radius. So that's it. So let's explain Roberto's mistake. And that's it. I've just written down he's not squared the radius. It should be x squared plus y squared equals 81. Now if we carry on, David says the equation of the circle is x squared minus y squared equals 81. Now David's almost correct. He's got the x squared, the y squared, and the 81, but it shouldn't be a minus. It should be a plus, because the equation of the circle is x squared plus y squared equals r squared. And that's it. So let's explain his mistake. And that's it. I've just written down he should not have used the subtract sign because it's x squared plus y squared equals 81. Okay, and if we carry on, we're told that Carl says the equation of the circle is x plus y equals 81. Explain Carl's mistake. So remember, it's x squared plus y squared equals r squared. Now he squared the radius, 9 squared is 81, but he's forgotten the square symbols above the x and the y. So let's write that down. So we're asked to explain Carl's mistake, so Carl has not included the square symbols. It should be x squared plus y squared equals 81, not x plus y equals 81. And that's it. Okay, let's have a look at our next question, question number 6. So question number 6, we've got this sketch. We've got our x-axis, our y-axis, and our circle. And we've been asked to write down the equation of the circle. Now this is a calculator question, just it might help us square the radius. Actually, I do know the 14 squared anyway. So the equation of the circle is x squared plus y squared equals r squared, because it's a circle with centre of the origin, so it's going to be x squared plus y squared, and that equals the radius squared. Now if we look at this circle, the radius of the circle, the distance from the centre to the edge, from here to here, is 14. We go 14 across from the centre to the edge. So the radius of the circle is 14, so it's going to be x squared plus y squared equals 14 squared. And we could leave it like that if we wanted to, but I'm going to square this. I'm going to work out 14 squared. So 14 squared is equal to 14 times 14 is 196. So that means the equation of the circle is x squared plus y squared equals 196. And that's it. Okay, next. Okay, let's have a look at our next question, question number 7. So question number 7 says a circle's got equation x squared plus y squared equals 144. And we've been asked to work out the length of the diameter of the circle. So remember, the equation of a circle is x squared plus y squared equals r squared. So to find the radius of the circle, we just need to square root the 144. So if we do the square root of 144, that'll tell us the radius of the circle, because the radius squared is 144. So the square root of 144 is 12, because 12 times 12 is 144. So that means the radius of the circle, the radius, is equal to 12. Now we want to find the diameter. Now the diameter the whole way across the circle will be double that. So 12 multiplied by 2 is equal to 24. So that means the diameter of the circle will be 24. And that's it. So we've been asked to work out the length of the diameter of the circle. That's 24. And we find that by square rooting 144 to get 12, which is the radius. And the diameter is double that, which would be 24. And that's it. Okay, let's have a look at our next question, question number 8. So question number 8 says a circle's got equation x squared plus y squared equals 316.84. We've been asked to find the radius of the circle. Now, this is a calculator question, so it's going to come in handy for this question. And the equation of a circle, well, that's x squared plus y squared equals the radius squared. So the radius squared is 316.84. So if we square root 316.84, we'll find the length of the radius of the circle. So we just need to square root that, and whenever you you on your calculator square root 316.84, you get an answer of 17.8. So the radius of the circle is 17.8, and that's it. So that's the radius of the circle, 17.8. If you're asked to find the diameter of the circle, you would double that. If you're asked to find the area of the circle, you would use this in pi r squared. If you're asked to find the circumference of the circle, you would double that to get the diameter and then multiply by pi and so on. But in this question, we're just asked to find the radius of the circle, so that's it, 17.8. Okay, let's have a look at our next question, question number 9. So question number 9 says a circle C has centre O, and the points A, which is 0, 7, and B, which is 0, negative 7, lie on C. So these 2 points lie on the circle C. And AB is the diameter of C, so the line joining A and B is the diameter of the circle. And part A says find the coordinates of centre O. So we want to find the coordinates of the centre of the circle. So if we've got the diameter of the circle, which is AB, if we find the midpoint of that diameter, that'll be the centre of the circle. So we've drawn a little sketch. Here's a sketch, and we've got the point A, which is 0, 7, and the point B, which is 0, negative 7. And as you can see, the midpoint of that line, the midpoint of that diameter, will be the point 0, 0, the origin. So that means the centre of the circle is the origin, 0, 0, and that's it. Okay, part B. Part B says write down the equation of the circle. So remember the equation of a circle at GCSE level is x squared plus y squared equals r squared. So we've got x squared plus y squared equals the radius. Now the radius of the circle, here we've got 0, 0, the centre of the circle, and the point A is 0, 7, so we've gone 7 up, so that means that the radius of the circle is 7. So the radius from here to here is 7. So that means it's going to be 7 squared, because it's the radius squared. And 7 squared is 49, so it's going to be x squared plus y squared equals 49, and that's it. That's the equation of the circle. Okay, let's have a look at our next question, question number 10. So question number 10, we're told that AB is the diameter of a circle C. So we've got the circle C, and AB is the diameter of it. We're told that O is the centre of the circle, and the point A has got coordinates negative 4, 3, and the point B has got coordinates 4, negative 3. And part A says find the centre of the circle O. So we want to find the coordinates of the centre of the circle. So if we know that AB is the diameter of the circle, the midpoint of that diameter will be the centre of the circle. So let's find the midpoint of these 2 coordinates. And to find the midpoint of these 2 coordinates, we'll add them together and half it. So we'll add the x coordinates together. So we'll do negative 4 plus 4 to negative 4 plus 4. Negative 4 plus 4 is equal to 0, and then we'll do 0 divided by 2 is equal to 0. So that means the x coordinate of the midpoint is 0, so that means the x coordinate of the centre of the circle is 0. And then in terms of the y coordinates, we'll add them together and half it. So we're going to do 3 plus negative 3, so we'll add together the y coordinates, and 3 plus negative 3 would be 0, and 0 divided by 2 is equal to 0. So that means the coordinates of the centre of the circle would be 0, 0. Okay, let's have a look at part B. So part B says find the equation of C. So we want to find the equation of the circle C. So I've just drawn a sketch of the circle. We know the centre of the circle is the origin, so I've just drawn the x-axis, the y-axis, and a circle with centre of the origin. And we want to find the equation of this circle. So remember the equation of a circle at GCSE level is x squared plus y squared equals r squared. So we need to find the radius of the circle. So let's consider one of the points. So I'm going to consider the point A, which is negative 4, 3. So negative 4, so negative 4 across, and 3 up will be here. So that's just where A is. That's a little sketch of where A would be. And we want to find the radius of the circle. So that's the distance from the centre of the circle to A. So I've joined those up, the centre of the circle and A, and we want to find the length of that line. So if we want to find the length of this line, we're going to consider Pythagoras' theorem. So we're going to consider a little right angle triangle, and I've just drawn a little right angle triangle there, a right angle in there. This is the origin, so we've got negative 4 across. That means the distance from here to here would be 4. And then we've gone 3 up, so that means the length of that line would be 3. So we've now got a right angle triangle where we know the length of the 2 shorter sides, and we want to find the length of the longer side, this length here. So we're going to use Pythagoras' theorem. So I'm just going to label that R because it's the radius of the circle. And that means if we consider Pythagoras' theorem, let's label the sides. We've got A and B being the 2 shorter sides, so the 3 and the 4 are the 2 shorter sides. And the longer side, the radius of the circle, will be C. So that means that A squared plus B squared equals C squared. And then if we substitute in our values, instead of A squared, we've got 3 squared plus, and instead of B squared, we've got 4 squared. And that's equal to C squared, and that's the radius squared. Now if we work this out, 3 squared is 9, and 4 squared is 16, and that's equal to the radius squared, so that's the radius squared. And 9 plus 16 is equal to 25, so we've got 25 is equal to the radius squared. And if we square root this, we're going to get that the radius is equal to 5. So that means the radius of the circle is 5. Now we were asked to find the equation of this circle. So the equation of the circle is x squared plus y squared equals r squared. So it's going to be x squared plus y squared equals, and we could write 5 squared here, or 5 squared is 25. So that means the equation of the circle would be x squared plus y squared equals 25, and that's it. And what we done was we used Pythagoras' theorem to find the radius of the circle, and then once we knew that, we then put that into the equation of the circle. Okay, part C. Part C says, should the point D, -3, -4, lies on C. So if this point lies on the circle C, we can just substitute in these values, the x coordinate and the y coordinate, into the equation, and we should find that that satisfies the equation. So let's do that. X squared plus y squared equals 25. X squared, well, that's going to be -3 squared plus y squared, which is -4 squared, should hopefully be equal to 25. Now let's work this out. -3 squared, that's -3 times -3, which is 9, because a negative times a negative is a positive, plus -4 times -4 is 16, and that should hopefully be equal to 25. Let's just check it. 9 plus 16 is 25, so we get 25 is equal to 25. So that's fantastic. So this point does satisfy the equation. So let's write that down. And that's it. I've just written, therefore, D does lie on C. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 11. So question number 11, we've been told that a circle below has got centre 0, 0. So the centre of the circle is the origin, and the point -15, 8 is a point on the circle. So this is a point on the circle, and we've been asked to find the equation of the circle. So the equation of the circle will be in the form of x squared plus y squared equals r squared, because the centre of the circle is the origin. And we just need to find the radius of the circle, because if we find the radius of the circle, we can then just substitute it into the equation and then work out the equation. Okay, so we want to find the radius of the circle. So that's going to be this distance here. So let's label the distance from the centre of the circle, the origin, to that point. So that's the distance we want to find. That's the radius of the circle. And let's turn this triangle into a right angle triangle. So let's just draw a little line down here and then just do a right angle. And we've got a right angle triangle here. And we know to get to this point, we're going to go to -15. So we're going to go 15 across this way. So that's 15. And then we're going to go up 8. So that's going to be up 8. And we want to find the length of this length here. So we're going to use Pythagoras' theorem, because we've got the length of the two shorter sides. So Pythagoras' theorem is a squared plus b squared equals c squared. Now we want to find the radius, so I'm just going to label that r, and we've got our two shorter sides, which are a and b, and we want to find the radius of the circle. So a squared plus b squared equals c squared. So let's substitute in our values. So we've got a and b being the two shorter sides, and the radius, which is opposite the right angle, will be the longest side, the hypotenuse. So let's label that c. So let's substitute in our values. Instead of a squared, we're going to write 8 squared plus, and instead of b squared, we're going to write 15 squared, and that's equal to c squared, which is the radius of the circle squared. Now, this is a calculator question, so you can just type this into your calculator at this point. 8 squared is equal to 64, plus 15 squared is 225, and that's equal to the radius squared. 64 plus 225 is equal to 289, and that's equal to the radius squared. So to find the radius of the circle, we now just need to square root. So the radius of the circle will be equal to the square root of 289, and when you do that on your calculator, you get that's equal to 17. So that means the radius of this circle is equal to 17, because the length of this line is 17. So that means the radius of this circle is equal to 17. So now we've got the equation of the circle being in the form of x squared plus y squared equals the radius squared. So it's going to be x squared plus y squared equals the radius, which is 17, because the length of that line is 17, so 17 squared. Now you could leave it like that, or you could square the 17, which is 289. So that's what I'm going to do. X squared plus y squared is equal to 289, and that's the equation of that circle, and that's it. Okay, let's have a look at our next question, question number 12. So question number 12 says, a circle shown below has got equation x squared plus y squared equals 36. And we've been asked to find the circumference of the circle and to give our answer in terms of pi. And that's quite handy because it's a non-calculator question, so being asked to give it in terms of pi is quite nice. So we've got this sketch of this circle, which has got equation x squared plus y squared equals 36. Now remember, it's x squared plus y squared is equal to the radius squared. So it means the radius squared is equal to 36. So if we square root 36, that'll be the radius, and the square root of 36 is 6. So that means the radius of the circle is 6. So it means the distance from here, the centre, to the edge is 6. So if we want to find the circumference of this circle, to find the circumference of the circle, we just do circumference equals pi times diameter. And if the radius, the distance from the centre to the edge, is 6, the whole way across, that's another 6, and 6 plus 6 would be 12. So that means the diameter of the circle will be 12. So we just need to do the circumference is equal to pi multiplied by 12. We've doubled the radius to get the diameter. And then we just need to give our answer in terms of pi. So pi times 12 would just be 12 pi. So it means the circumference of the circle is 12 pi, and that's it. Okay, let's have a look at our next question, question number 13. So question number 13 says a circle's got equation x squared plus y squared equals 121. And this time we've been asked to find the area of the circle and to give our answer in terms of pi. And again, it's a non-calculator question, which is quite nice. Okay, so the equation of the circle is in the form x squared plus y squared is equal to the radius squared. Now here we've got 121 as the radius squared, so if we square root 121, that's going to be the radius of the circle. So the square root of 121 will be 11, because 11 times 11 is 121. So it means the radius of the circle is equal to 11. Now we want to find the area of the circle. So the area of the circle, well, area is equal to pi r squared. So we just need to do pi multiplied by the radius, which is 11 squared. And 11 squared, this is a non-calculator question, so we're going to work this out. 11 squared, remember our order of operations, we have to square first of all, we square the radius and then multiply by pi. So 11 squared is equal to 121, so it's going to be pi multiplied by 121. And then we've been asked to give our answer in terms of pi, so we just need to put these together. So it's going to be 121 pi, and that's it. So our answer is 121 pi. Okay, question number 14. Okay, so question number 14 says, shown below are two circles with centre O. So we've got these two circles with centre O. So there's the centre O, the origin, 0, 0. And we've got our first circle and our second circle. And the question says, the equation of the smaller circle is x squared plus y squared equals 400. So the equation of this smaller circle is x squared plus y squared is equal to 400. Now the equation of a circle is in the form x squared plus y squared is equal to the radius squared. That means the radius squared is 400. So if we square root 400, the square root of 400 would be 20, because 20 times 20 is 400. So that means the radius of the smaller circle is 20. So the distance from here to here would be 20, or from here to here, here to here, here to actually any point on that circle, that smaller circle, here to here, would be 20, that distance. So the radius of that smaller circle is 20. And then the question says, we've got a ratio, we've got the radius of the smaller circle to the radius of the larger circle is 5 to 6. So if we know the radius of the smaller circle, to find the radius of the larger circle, we just need to divide by 5 and multiply by 6. We divide the 20 by its number in the ratio, the 5, and then multiply that by 6 to find the radius of the larger circle. So if we take our 20, and if we divide that by 5, because the radius of the smaller circle, it's got 5 parts, so 20 divided by 5 is equal to 4. And then if we take our 4 multiplied by the number of parts for the radius of the larger circle, which is 6, and 4 times 6 is 24. So that means the radius of the smaller circle is 20, and the radius of the larger circle from here to here, so there to there, would be 24. So we've got the radius of the smaller circle and the radius of the larger circle. And the question says work out the equation of the larger circle. So remember, it's in the form x squared plus y squared equals the radius squared. So it's going to be x squared plus y squared is equal to the radius. So the radius of the larger circle is 24, so 24 squared. Now we could leave it like that, or we could square the 24. And it's a calculator question, so I'm going to square that 24. So x squared plus y squared is equal to 576. So that means the equation of the larger circle is x squared plus y squared is equal to 576. And that's it. Okay, so let's have a look at question number 15. So question number 15 says, circle's got equation x squared plus y squared equals 25, and a straight line, this green straight line, meets a circle at the points A, which is A2, so A across and 2 up, and B, which is B2, so B across and 2 up. And part A says, write down the equation of the straight line. So we know this point has got a height of 2, and this point's got a height of 2, and it's a horizontal line going through 2 in the y-axis. So the equation of that line would be y equals 2. So that's the equation of that horizontal line. So let's write that down. Y equals 2. Okay, part B. Part B says write down the coordinates of the points A and B and to give our answer in third form. So we want to find the coordinates of this point and the coordinates of this point, and we want to give our answer in third form because it's a non-calculator question. So we've got this circle and this straight line, and if we want to find the coordinates of the points of intersection, we just need to solve the simultaneous equations. So we've got our first equation, which is x squared plus y squared equals 25, and our second equation, which is y equals 2. So we've got the equation of the circle, and we're going to substitute 2 in for y because we know that y is equal to 2, so we're going to substitute that into the equation of the circle. So it's going to give us x squared plus 2 squared is equal to 25. And if we work this out, 2 squared is 4, so that'll be x squared plus 4 is equal to 25. Now let's solve this equation, so let's take away 4 from both sides. So if we take away 4 from the left hand side, we'll just be left with x squared. And on the right hand side, we have 25, we're taking away 4, so that's going to be 21. So we've now got x squared is equal to 21. So we want to solve this, so we're going to solve this equation. So we want to get rid of the squared. And remember, we can have a positive solution here and a negative solution, because a positive number squared will give us 21, And a negative number squared will also give us 21. So that means that x will be equal to plus or minus, and the square root of 21 is the square root of 21, or root 21. So that means that x is equal to the square root of 21 or minus the square root of 21. So if we consider this point A here, well, if you think about it, it's going to be negative the square root of 21 because the x coordinate at this point will be negative. So A will be minus the square root of 21 and then 2 because it's 2 up. And then in terms of this point B, it's going to be the square root of 21 across and then 2 up. So the square root of 21 or root 21, 2, and that's it. So they're the coordinates of those 2 points. The coordinates of the point A would be minus the square root of 21, 2, and then the coordinates of the point B would be the square root of 21, 2, and that's it. So let's write that down. So question number 16, we've got these set of axes, our x-axis and our y-axis, and we've got this circle. And the question says the point P, which is this point here, has got coordinates -2, -5. And it's a point on the circle with centre 0, 0. So this circle is centre 0, 0. So that means the equation of this circle will be in the form of x squared plus y squared equals r squared, because the centre of the circle is the origin. Now the question says work out the diameter of the circle. So we want to work out the diameter of the circle, so the distance from one side of the circle to the other side of the circle. So what I'm going to do in this question is I'm actually going to find the radius first of all. I'm going to find the distance from the origin to P. So I'm going to find the length of this line here. And I can find the length of this line by using a right angle triangle and Pythagoras' theorem. So I'm going to turn this into a right angle triangle by going up like so. And that's a right angle triangle. And because this is the point -2, -5, if we're at the origin, we would go 2 to the left. So the length of this line here, this part of the triangle, is 2. And then we're going to go down 5. So that means the length of that side of the triangle would be 5. And then if we use Pythagoras' theorem, we can find the length of the hypotenuse, and that would be the radius of the circle. So let's do that. So Pythagoras' theorem is a squared plus b squared equals c squared, and the two shorter sides are the a and the b, which are 2 and 5. So it's going to be 2 squared plus 5 squared equals the radius squared. 2 squared is 4, so it's going to be 4, plus 5 squared is 25, and that equals the radius squared. 4 plus 25 is 29, so 29 equals the radius squared. And if we square root that, we get the radius is equal to the square root of 29. So that means the radius of the circle is equal to root 29. So that's the radius of the circle. But in this question, we've been asked to work out the diameter of the circle and to give our answer as a third. So we want to find the diameter of the circle. So to find the diameter of a circle, you can just double the radius. So the diameter would be equal to 2 multiplied by, or double, root 29. So 2 times root 29. And then we just put these together, so that'll be 2 root 29. So that means the diameter of the circle is equal to 2 root 29. And that's it. So we found the length of the radius by using Pythagoras' theorem, and then we just doubled it. And that's it. Okay, let's have a look at our next question. Question number 17. So question number 17 says the circle below has got equation x squared plus y squared equals 4. So remember 4 is equal to the radius squared, so if we square root that, the square root of 4 is 2, so that means the radius of the circle is 2. And as you can see, if we start at the origin and we go across to 2, that means the radius is 2. So it's a circle with radius 2 and the centre is the origin. And then we've got a line, and this line has got equation y equals x minus 4. So that's the equation of that line. It's a line with a gradient of 1, because it's 1x, and it has a y-intercept of minus 4. And as you can see, it crosses the y-axis at minus 4. So we've got this circle, and we've got this straight line. And then if we read the question, it says, find the area of the shaded region. So we want to find the area of the shaded region, this green region here. So if we want to find the area of this shaded region, what I'm going to do is I'm going to work out the area of this whole triangle. So if we work out the area of this whole triangle, this triangle here that I'm showing using these little dashes, so we find the area of that triangle, and then we find the area of this quarter circle. If we take the area of the quarter circle away from the whole area of the triangle, what's left would be this shaded region, this area of this green region here. So let's do that. So in terms of the triangle, the area of the triangle, so in terms of the area of the triangle, that's half the base times the height. So it's going to be half the base. Now we can either look at it this way. If it's upside down, the base would be 4 and the height would be 4. Or you could turn your head sideways and say the base is 4 and the height is 4. But the base and the height are 4 and 4. So the area of the triangle, the area would be equal to half multiplied by the base, which is 4, multiplied by the height, which is 4. And half of 4 is 2, and times 4 would be 8, so it would be equal to 8. Or you could do 4 times 4 is 16, and then half it would be 8. So the area of that triangle is 8. Now we want to find the area of the quarter circle, so the area of the quarter circle. And to get the area of the quarter circle, I'm going to get the area of the whole circle. So I'm going to do pi r squared for the whole circle, and then divide by 4. So the area of the whole circle, well, it's going to be area of the circle. So the area of the circle is pi multiplied by the radius squared. The radius of the whole circle is 2, because from here to here is 2. So we're going to do pi multiplied by 2 squared. And 2 squared is 4, so that's pi times 4. And pi times 4 is 4 pi. So that means the area of the whole circle is 4 pi. Now we want to find the area of this quarter circle, this region here. So if we take the area of the whole circle, which is 4 pi, and divide it by 4, that'll be the area of the quarter circle. So let's do that. So the area of the quarter circle would be the area of the whole circle, which is 4 pi. So the area of this whole circle is 4 pi. And then we divide by 4, and 4 pi divided by 4 would just be pi. So that means the area of this quarter circle here is pi. So if we want to find the area of the shaded region, we're going to take the area of the whole triangle, which is 8, and we're going to subtract the area of the quarter circle, which is pi. So that means the area of the shaded region would be 8 subtract pi. So let's write that down. And that's it. The area of the shaded region would be 8 subtract pi. Or if we wrote it as a decimal, it would be 4.8584 and so on. And that's the area of that shaded region. Okay, and then part B. Part B says find the perimeter of the shaded region. So we want to find the perimeter of the shaded region. So I'm just going to get rid of those lines that I've put in, those little dashes that I've put in already. And we want to find the perimeter of the shaded region. So that's that distance plus that distance, that diagonal line there, plus that distance, and then plus that distance there, around there. And if we add those 4 lengths together, that length, that length, that length, and then that curve, that'll give us the perimeter of that shaded region. Okay, now let's find the lengths of this part and this part to begin with, because that's quite straightforward. That's 2 on the x-axis, that's 4 on the x-axis, so the length of this part would be 2. And the height here is -2, and this is -4, so the length of this part is 2 as well. So we find the length of 2 of the sides, now we just need to find the length of this arc and the length of this line. Okay, so let's start off with the length of the arc. So to find the length of this arc from here around to here, what we're going to do is we're going to find the circumference of the whole circle and then divide by 4. And that gives us the length of the arc. So let's find the circumference of the circle. The circumference would be equal to pi multiplied by the diameter. The diameter of the whole circle, well, that's going to be from -2 to 2. The diameter of the whole circle is 4, and we know the radius was 2, and double 2 is 4. So it's going to be pi times 4, which is 4 pi. So that's the circumference of the whole circle. Now in terms of the length of the arc, that's a quarter of the whole circle. So we're going to take the 4 pi and then we're going to divide that by 4, and 4 pi divided by 4 would be pi. So that means this arc, the length of this arc from here around to here would be pi. So we've now found the length of that side, that's 2. We've found the length of the arc, which is pi. We've found the length of that side, which is 2. And now we just need to find the length of this line. And as you can see, it's a diagonal line, so we're going to use Pythagoras' theorem. And as you can see, here's a right angle triangle. This triangle, here's a right angle triangle. There's a right angle. And this distance here is 4. And this distance is 4. And they're the two shorter sides. So if we do Pythagoras' theorem using 4 and 4, we can find the length of the longest side, that hypotenuse. So let's do that. So we're going to do, let's just sketch it. So here's a little sketch. We've got the origin here. So that's the origin. We've got the length of that line's 4. The length of that line's 4. And we want to find the length of that line. So that's going to be Pythagoras' theorem, which is a squared plus b squared equals c squared. A squared and b squared, well, that's the two shorter sides. So it's going to be 4 squared plus 4 squared. And that equals c squared. 4 squared is 16. So we've got 16 plus 16 is equal to c squared. So that means that c squared would be equal to 32. And then we just square root. C would be equal to the square root of 32. So that means the length of that line from here to here would be root 32. So root 32 or 4 root 2. We could write it as 4 root 2 if we wanted to, 4 root 2. And the length of that line is 4 root 2. So if we go back up, we've now got the length of that part, which is 2, the length of that arc, which is pi, the length of this line, which is 2, and the length of this line here, which is equal to 4 root 2 or root 32, depending on how we want to write it. So I'm going to write 4 root 2. You could write root 32 there. And now we want to find the perimeter of this region. We just need to add them together. So let's do that. So we're going to do 2 plus pi plus 2 plus 4 root 2. And if we add those together, we get 12.798. And that's the 3 decimal places. And that's it. That's the perimeter of that shaded region. Okay, let's have a look at our next question, question number 18. So question number 18 says, shown is a sketch of a circle with equation x squared plus y squared equals 49. So the equation of the circle is x squared plus y squared equals 49. And if we square root 49, that's 7. So the radius of the circle is 7. And as you can see, the radius is 7. And then the question says, the circle is translated, so it's translated or slid, 3 squares downwards. So it's going to be moved 3 squares down. And the question says, sketch the circle and label the coordinates where the circle crosses both the x-axis and the y-axis. So let's do a little sketch. So here's our x-axis and y-axis. So here's our circle to begin with, and it's translated 3 squares down, so it's going to move down. Now one thing to note is the top of the circle is still above the x-axis, because if we look at this, the top of the circle across the x-axis is 7. If we translate that 3 squares down, it's not going to go below the x-axis, it's going to be up here somewhere. Okay, so let's find the points of where that circle crosses both the x-axis and y-axis. And I'm going to start with the y-axis to begin with, because they're the easiest ones to do. So if we have a look at this point, this is the point 0, 7, and we're going to translate it 3 squares downwards. So that means the top of the circle will be at 0, 4. So that means this point here is 0, 4. because we've moved it 3 squares down. Then if we look at the bottom of the circle, it crossed the y-axis at -7, and then we're going to translate it 3 squares down, so it'll be -10. So if we have a look here, that's going to be, this point here would be 0, -10. So we've got the 2 points where the circle crosses the y-axis. Now let's find where the circle crosses the x-axis. Now what I'm going to do is I'm actually going to go back up to the original circle, and I'm going to draw the line y equals 3. So if I draw the line y equals 3, the line y equals 3 would look like this. So I've just drawn the graph of the line y equals 3, and as you can see, the circle crosses that line y equals 3 in 2 different locations, here and here. Now we've translated the circle 3 squares down. And so we translated the circle 3 squares down, it looks like that. Now if we translated the graph of y equals 3 squares down, well, if we translated it 3 squares down, it would then be on top of the x-axis. So this point and this point here, they would have the same x coordinates as this point and this point, because if we translate this 3 squares down, then that would go on top of the x-axis. So what we're going to do is we're going to find where this straight line and this circle intersect. So we're going to find the coordinates of this point and this point. So let's do that. Let's find the coordinates of that point and that point. So here we've got a circle with equation x squared plus y squared equals 49, and we've got the line y equals 3. So let's substitute 3 into y. So we'd have x squared plus, and instead of y squared, it's going to be 3 squared equals 49. And then 3 squared is 9, so we're going to get that x squared plus 9 is equal to 49. And then if we take away 9 and take away 9, we're going to get that x squared equals 40. And that means if we square root, we're going to get that x is equal to plus or minus the square root of 40. And the square root of 40 is 2 root 10. So that means that x is equal to plus or minus 2 root 10. So that means that this point here would have coordinates negative 2 root 10, and then the height would be 3. And this point would have coordinates 2 root 10, and then the height would be 3. So we've got the coordinates of where this straight line y equals 3 and the circle intersect. And then if we translated it down 3 squares downwards, it would look like this. And then that means that this point here would be, this point here where it crosses the x-axis would be negative 2 root 10, 0. And this point here would be 2 root 10, 0. And that's it. So we've sketched the circle after the translation. So we've sketched the circle after it's been translated 3 squares down. And we've found the coordinates of where that circle crosses the x-axis, here and here, and crosses the y-axis, here and here. And that's it. Okay, let's have a look at our next question, question number 19. So question number 19 says a circle has got equation x squared plus y squared equals 40, and a straight line has got equation y equals 3x. And the line intersects a circle at 2 points P and Q, and we've been asked to find the coordinates of P and Q. Now, I've drawn a sketch for this question. Now, you can actually do this question without drawing a sketch. You could just solve the simultaneous equations and find the solutions, and they'll tell you the coordinates of where the straight line and the circle intersect. So you could just replace this y with 3x, and then do x squared plus 3x all squared equals 40, and then solve that to find the values for x, and then substitute those in to get the values for y, and there'll be your coordinates. I'm actually just going to do a little sketch just to show you this. So just on a little sketch where we've got our straight line y equals 3x, so it's a line going through the origin, and with a gradient of 3. And we've also got our circle, which is x squared plus y squared equals 40. So the radius of that circle will be root 40. The square root of this is root 40 would be the radius of the circle. Okay, so we've been asked to find the coordinates of P and Q, so it's going to be P there and Q there. So let's find the coordinates of those 2 points. Okay, so to find the coordinates of these 2 points, we're going to solve these simultaneous equations. We're going to substitute the 3x in for y here. So we've got x squared plus, and then instead of y, it's going to be 3x, and I've just put that in brackets, squared equals 40. So we've got x squared, and then 3x squared would be 3x times 3x, which would be 9x squared, so plus 9x squared equals 40. And then x squared plus 9x squared would be 10x squared, and that equals 40. And then if we solve this, let's divide both sides of this equation by 10. We're going to get that x squared equals 4. So we've now got x squared equals 4. So that means that x equals 2, or x equals negative 2. So x will be equal to plus or minus 2. So now if we've found our values for x, or x coordinates, that means this point has got an x coordinate of negative 2, and this point has got an x coordinate of 2. So to find the y coordinates, what I'm going to do is I'm going to substitute the values for x into y equals 3x. So we've got y equals 3x. When x equals 2, when x equals 2, we'd have y equals 3 times 2, which is equal to 6. So it's going to be 2, 6, so 2, 6. And this point here, and whenever x equals negative 2, we'd have y equals 3 times negative 2. And 3 times negative 2 is negative 6. So that'd be negative 2, negative 6. So that means the coordinates of the point P are negative 2, negative 6. And the coordinates of the point Q are 2, 6. And that's it. Okay, let's have a look at our next question, question number 20. So question number 20 says a circle C has got equation x squared plus y squared equals 16. And the circle is reflected in the line x equals -4 to give the circle D. And the circle D is then translated by the vector 0, 2 to give the circle E. Write down the coordinates of the centre of circle E. So we want to find the coordinates of the centre of this circle E. So let's find out where that circle is. So I'm going to start off by sketching circle C. So circle C is a circle, the centre is the origin, and the radius of the circle would be 4 because the square root of 16 is 4. So let's sketch that circle. Okay, so I've just sketched a circle, x squared plus y squared equals 16, that's circle C, and it's got a radius of 4, so that means the centre of the circle is the origin, the point 0, 0, and it's going to pass through these points, 4, 0, 0, -4, -4, 0, and 0, 4. And then we're told that that circle is reflected in the line x equals -4. So x equals -4, it's a vertical line passing through -4 in the x-axis, so it looks something like this. So that's the line x equals -4. It's a vertical line passing through 4 in the x-axis. All these points on this line will have an x-coordinate of -4. And this circle is reflected in that line. So this circle is going to move over here somewhere. So let's reflect that circle. Okay, so we've reflected circle C to get circle D. I've just drawn the circle after the reflection, and I've also extended the x-axis. This point here is on the mirror line, so that's the point -4, 0. So that point's on the circle. The circle has got a radius of 4, so that means that if this point is -4, 0, the centre of the circle will be 4 across, so that'll be -8, 0. And this point over here would be -12, 0. This point down here, if I go down 4, would be -8, -4, and this point up here it would be -8, 4. So that's circle D, and then we're told that circle D is translated by the vector 0, 2. So that translation 0, 2 means 0 left or right and 2 up. So this circle is going to be translated 2 squares upwards to give us circle E. And we've been asked to write down the coordinates at the centre of circle E. So let's do that. So let's translate this circle 2 squares up. So we've translated that circle, this circle D, 2 squares upwards to give us circle E. And we've been asked to find the coordinates of the centre of that circle. So the coordinates of the centre of circle D was -8, 0. So if we translate it up 2 squares, so up to here somewhere, the centre of that circle E will be here somewhere, that'll be the point -8, 2. And that's it. They're the coordinates of the centre of that circle E, because the centre of circle D was -2, 0. If we translate it 2 squares upwards, it'll be -8, 2. And that's it. So the coordinates of the centre of that circle will be -8, 2. And that's it. And that's it. So in this video, we've gone through the video solutions to the equation of a circle practice questions. If you need any extra help on the equation of a circle, you could scan this QR code. Alternatively, you could go to Corbettmaths, go to the videos and worksheets section and scroll down to video number 12. And there's a dedicated video tutorial there on the equation of a circle. But in this video, we'll focus on the video solutions to the practice questions. I really hope you found it useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.